All right, guys, this is chapter 6, section 2, example number 6. This is very similar to example number 5, except it's actually telling you to determine the determinant of each matrix, then find the inverse if it exists. So just going straight into this would be 2 times 4, which is 8, minus negative 3 times 4, which is negative 12. So this gives me 8 plus 12, which gives me a value of 20 for the determinant. Since I know that the determinant is a value, a number that is not 0, then I can go ahead and solve for the inverse. That means I would be multiplying by 1 over 20. Then I would swap the 2 and 4 to get 4 and 2, change the signs of a negative 3 to a positive 3, and a positive 4 to a negative 4. Then we're actually going to get to see where we're multiplying through each term by something that's not just a 1 or it does not exist. If I multiply each term through by 1/20th, 1/20th times 4 gives me 1/5, 3 over 20, negative 1/5, and 1/10. So my answers are in fraction form. If you're choosing to put this into your calculator, which is okay, I would take matrix A, and then I would actually raise it to the negative 1. The problem is this actually gives it to you in decimals, and decimals a lot of times are not going to be satisfactory to your professors or to this teacher. So what you want to do is make sure that you change it to a fraction form, which you can do by pressing math, and then the very first option is fraction, and just press enter and it'll automatically change the matrix for you. Okay, on part B, we're determining this determinant. 6 times 6 is 36 minus 4 times 9, which is 36. This gives me a determinant of 0, and then I'm supposed to find the inverse if it exists. Well, because I have a determinant of 0, I can simply say that this is a singular matrix, meaning it does not have an inverse. And that is it for example 6.